It's been said that the top three things that will deteriorate a house are moisture, moisture, and moisture. Kind of a cliche perhaps, but realistically, moisture is what will damage a house, and so we've got to make sure that moisture stays out of the structure. And anytime we have two different components of a house coming together, there needs to be some sort of a transition. And that transition material we'll call a flashing. Moisture will always follow the path of least resistance. And so we want to give it the correct path so it will always come to the exterior. Let's just start up here just for a moment at the roof. It's recommended, although perhaps not required, that there be a drip flashing at the roof. The drip flashing would serve the purpose of the last drips of rain coming off of that roof are going to drip off of something that they cannot soak into, like wood. If there were no drip flashing, there would be, say, perhaps a short extension of shingle or whatever. But that is, again, a transition to get that water to go somewhere else. As we come down the wall of the house, we have a transition necessary when we meet a window or the top of a door. Now, the proper flashing would be behind the siding and then come out over and let the water drip off in front of the window. Sometimes the window manufacturer has specifications that say it's not necessary. We will never know that. So we can always err on the side of caution and say we want to see a flashing over the top of a window. On older houses, sometimes you'll see a wood flashing. Actually a piece of shaped wood that tucks up behind that first bit of the old clapboard type siding and actually reaches out in front of the window. Once again, it is just to bring that water out to the surface. Oh, I messed it up. Here we go. Lost where my props were. Here is a flashing that would be bringing it out in front of a window. Okay, as long as I have the board in front of me, here's another flashing that would be between two pieces of plywood type siding. If there was a horizontal seam, this flashing would reach up behind the upper one, bring the water out to the front of the lower one, and from there it's out at the surface. Okay? And here's the one that, again, a metal one that would be over a window. We'll set that back down here. Let's just say we've got a situation where, I'll use my prop once again. Let's pretend that this is a two-story portion of the house and that there's a one-story addition to the house and it has a roof that is meeting a wall. Once again, we've got a transition between two components of the house. What's going to be necessary there is some sort of flashing, we'll call it a kick-out flashing, that brings that water out away from the wall, because quite often that one story might actually end back here where there's still some more wall in front of it. So the water gets channeled away from that wall so it doesn't run down the wall. Over here we've got a display of that, perhaps. This would be the kick-out flashing. I've set this at an angle to simulate a roof once again. The shingles on this roof would be here, and as the water comes down this wall, it follows these flashings and kicks out away from that wall. Now, to get the water on top of or in front of this flashing, we've got one in this case which would tuck into a groove, into a saw kerf perhaps, of stucco or masonry wall. It's got what's called a riglet. The top of it would tuck back into the kerf, but then have a fishhook kind of shape so that as that goes in, water, even if it tried to get in on top of that flashing, cannot go in, would have to come back out. Okay? Now let's come back to the front of that flashing once again. Just real briefly, let me mention that if this was a shingled roof right here, this flashing would interlace with those shingles so that any water coming down would always be drawn out to the face of the shingles once again. Okay? Let's go to one more situation where we definitely need a flashing. Water is coming down on this wall from rain, and we get to the point where it encounters a deck. Let's go back to this example of the flashing here once again. A flashing of this particular shape, which would be on the wall, behind the siding, bringing the water out in front of the ledger board so it cannot get back in between. If water gets in between that ledger board and the house, it is trapped. It will deteriorate both the ledger board and, unfortunately, the house. There can be some very serious damage in that case. So just the thing to remember is, water will follow the path of least resistance. We always want that path to be out to the surface. So anytime there are two building components that interact, there definitely needs to be a flashing.